Today we're doing math pages 145 and 146. Okay, we're going to look at the yellow box at the top of the math page. Before we do, let me read the verse. Matthew 7:14. Because straight is the gate, and narrow is the way, which leadeth unto life, and few there be that find it. Okay, and our fact in the box says fractions must have a common denominator before they can be added or subtracted. And say this phrase with me. To add or subtract fractions, you must have common denominators. Ready, everybody, right now? To add or subtract fractions, you must have common denominators. Again, to add or subtract fractions, you must have common denominators. Again, to add or subtract fractions, you must have common denominators. Look, it says in our little picture here, to add or subtract fractions, you need a common denominator. And that's what we're going to look at first. So they have the example here, 2/5 plus 1/4 plus 1/2. So notice that the denominators are all different. They're all different. And what they've done is they've changed them. They found out an LCD, step 1, find the LCD of 5, 4, and 2. What they've done is they looked at their 5, their 4, and their 2. And they figured out what the LCD for those are. Well, what does 5, 4, and 2 all go into? It's 20. 5, 4, and 2 all go into 20. So the first step was figuring out what the LCD was. And then they changed all the denominators to 20, in which we just circled those. 20, 20, 20. And with that, they made equivalent fractions by 5 times what equals the 20? Well, 5 times 4 equals 20. So if they did a times 4 there, they had to then do a times 4 up here. 2 times 4, and they came up with 8, and that's correct. And they did that with all the numbers there. And then they added up their fractions. Once they had a common denominator, because, say it with me, to add or subtract fractions, you must have a common denominator. And they did that. They added 8 plus 5 plus 10. And that gave them 23. And they put a 20 on the bottom. So they get 23 over 20. That's improper, so they had to make it proper. 20 goes into 23 one time with 3 left over. And we see that being done right there. So to add or subtract fractions, it's saying you need a common denominator. Then you add or subtract the numerators, the top numbers. And keep the denominator the same in your answer. So let's go ahead and do some of class practice. We'll look at 1A. 1A is somewhat review. We're trying to write the missing terms. Okay, 8 times what equals 16? 8 times, let me back up here. 8 times what is 16? 8 times 2 is 16. So since we do a times 2 there, we got to do a times 2 on the top. 3 times 2 is 6. 6 over 16. Okay, B, 9 times what is 27? 9 times 3. So then we need to do a 5 times 3. That gives us 15. C, 5 times what is 10? 5 times 2 So if we do a times 2 there, we got to do a times 2 on top. 3 times 2 is 6. D. 4 times what is 12? 4 times 3 is 12. So times 3, let's do 1 times 3, and that gives us 3. Okay, number 2, it says write the least common denominator of these fractions. So we're looking at the denominators, 2 and 3. What's the lowest number that 2 and 3 both go into? 2 and 3 both go into 6. B, we have 3 numbers, 5, 3, and 15. What's the lowest number that 5, 3, and 15 all go into? Lowest would be 15. C, our denominators are 9, 3, and 6. What's the lowest number that 9, 3, and 6 go into? Well, 9 goes into 9, and 3 goes into 9, but 6 doesn't. So then you look at your biggest number, 9 goes into 18, 3 goes into 18, and 6 goes into 18, so 18 is our answer. 8 and 6. The lowest number that 8 and 6 goes into is 24. Okay, number 3. It's telling us to add after finding the least common denominator. That's what we did when we looked at this. And making equivalent fractions. Your answers should always be in the lowest terms, meaning if it can be reduced or if it needs to be made proper, I want that done. Okay, so let's look at A, 1/4 plus 1/2. And remember, to be able to add or subtract fractions, you must have common denominators. Now, our denominators are not the same, but we ask ourselves, what does 4 and 2 both go into? 4 and 2 both go into 4, so that's our first step. So we know they both go into 4. 4 times what equals 4? Well, 4 times 1 equals 4. So if we do a times 1 there, we then need to do a times 1 here. 1 times 1 is 1. 2 times what equals 4? Well, 2 times 2 equals 4. If we do a times 2 there, we need to do a times 2 on top. 1 times 2 is 2. Now we can add because we have common denominators. We have a 4 and a 4. To add or subtract fractions, you must have common denominators. We know our denominator and the answer will be 4. 1 plus 2 is 3. And so our first answer here is 3/4. Let's look at B. We don't have common denominators, but to add or subtract fractions, you must have common denominators. What does 8 and 4 both go into? 8 and 4 both go into 8. Now we got to figure out our top numbers. 8 times what equals 8? 8 times 1 equals 8. So if we do a times 1 here, we then need to do a times 1 here. 3 times 1 is 3. 4 times what equals 8? 4 times 2 equals 8. If we do a times 2 here, we must do a times 2 on top. 1 times 2 equals 2. And now we can add because we have common denominators. 3 plus 2 is 5, and then our 8 stays the same for our denominator. We have, for our answer, 5/8. C. Now this is a little different because we have a mixed number. A mixed number meaning we have a whole number and we have a fraction. And we're adding and subtracting mixed numbers now. But our problem is, to add or subtract fractions, you must have common denominators. And we don't. We have a 2 and a 3. They're not the same. But we got to figure out what is our LCD, or LCM, our lowest common denominator here. What does 2 and 3 both go into? The lowest number that 2 and 3 both goes into is 6. So I'm going to now bring my whole numbers over, 4 and 6. And I got to figure out 2 times what equals the 6. 2 times 3 is 6. So I now need to do the top number times 3 as well. And 1 times 3 is 3. Now let's look at the bottom. 3 times what is 6? 3 times 2 is 6. So I need to do 1 times 2. That gives us 2. Now we can add. Our denominator will be 6, and we add our 3 plus 2. 3 plus 2 is 5. Let's add our whole numbers, 4 plus 6, and that's 10. It can't be reduced, so we are finished with 10 and 5/6. Let's look at D. Okay, we don't have common denominators. We have a 5 and a 2. We have to make them the same. What does 5 and 2 both go into? The lowest number that 5 and 2 both goes into is 10. I'll bring over my whole numbers. 5 times what is 10? 5 times 2 is 10. So times 2, I need to do 2 times 2 also. 2 times 2 is 4. 2 times what is 10? 2 times 5 is 10, so I need to do 1 times 5. And that's 5. Let's add this up. 4 plus 5 is 9 over 10. 3 plus 1 is 4. And we get 4 and 9/10. Okay, as we turn the page over and we look at number 4, we're now subtracting. Doing the same thing, but we're subtracting now. But remember in our rules that we keep repeating, to add or subtract, you must have common denominators. So here we need to ask ourselves, what is 2 and 3? What's the lowest number they both go into? The lowest number they both go into is 6. Two times what equals 6? 2 times 3 equals 6. So if we do a times 3 there, we need to do a times 3 on top. And 1 times 3 is 3. 3 times what equals 6? 3 times 2 equals 6. So if we do a times 2 there, we need to do a times 2 on top. 1 times 2 is 2. And now we're able to subtract. 3 minus 2 is 1/6. Our answer can't be reduced, so we are done with 1/6. B. What does 5 and 10 both go into? What is our LCD for 5 and 10? 10 is the lowest number they both go into. Five times what is 10? 5 times 2 is 10. So we'll do a times 2 on top. 4 times 2 is 8. 10 times 1 is 10, so we'll do a times 1 on the top. 3 times 1 is 3. Now we can subtract. 8 minus 3 is 5. And then our denominator is 10. We don't want to circle it yet, though, because this one can be reduced. What goes into 5 and 10? 5 does. 5 goes into 5 one time. 5 goes into 10 two times. And now we've reduced like the directions told us to do, and we're done with that one. C. We've got a mixed number and a fraction here. To add this, we still need a common denominator, so we're changing our 7 and our 14 to a number that's the same. What's the LCD for 7 and 14, the lowest common denominator for 7 and 14? It'd be 14. So we're going to bring everything over with the 14 on the bottom. 2 and something over 14, and something over 14. 7 times what is 14? 7 times 2. So we need to do 6 times 2. 6 times 2 is 12. 14 times what is 14? Well, that's easy. 14 times 1 is 14. So times 1 will be here too. 3 times 1 is 3. And now we can subtract. 12 minus 3 is 9. Keep the 14 as our denominator. The 2 comes down here. That can't be reduced, so we are done. 2 and 9/14. 2 and 9/14. D. Okay, we got to make common denominators. I'm just bringing the whole numbers over first here. What does 2 and 4 both go into? 2 and 4 both goes into 4. That's the LCD for 2 and 4. 2 times what is 4? 2 times 2 is 4, so we need to do a 1 times 2. 4 times what is 4? Well, 4 times 1. So 1 times 1 goes on top, and that is 1. Now we can subtract. 2 minus 1 is 1. 4 becomes our denominator. 5 minus 2 is 3. And our answer is 3 and 1/4. Now you'll do the rest on your own. I need to let you know something before you do. Crickets are cool. And here's a whole bunch of different kinds of crickets here. And I want to show you something that has to do with math that can be really interesting with crickets. Now you know crickets, they make the noise, chirp, 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 chirp. It's like this chirp noise over and over and over and over and over again. Here it is once, twice, 3 times, 4 times, and so on. And it continues. Okay, let me show you why they're cool here. Okay, they can tell you what the temperature is. And you might think, wait a minute, crickets don't talk. How are they going to be able to tell me the temperature? This is really interesting, I think. Now, the outdoor temperature, what it is outside, it can be estimated. You know, it may not be exact, but it'll be close, within a few degrees, by timing the chirps of a cricket. And so, I'll show you here. You take the cricket's chirps, and you time it in 14 seconds. Every time it chirps, count it, and do it for 14 seconds. And then you add 40 to get the temperature. So let's say you counted how many times the cricket chirped, and let's say you counted, we'll say it chirped 35 times. In 14 seconds, chirped 35 times. Then you add 40 to it. And when I add that, it would be 75 degrees. Now let's say, here I'll erase it, I'll make a new one here. Let's say you counted it, and it was, I'll make up another number here, 42 times in the 14 seconds. Well, then it'd be 82 degrees outside. So kind of crazy if you ever are listening to a cricket chirp. And if you're ever annoyed with it, maybe think, oh, it's kind of cool because I can tell the temperature. I told you they're cool. Go ahead and do the rest on your own. I know you guys can. You are so smart. Crickets are kind of smart too.